Et je vais laisser la parole à Aravin, qui va vous parler in English. Aravin est directeur de la stratégie dans Tomorrow.io. On vous parlera, je pense, de Tomorrow. Et il anime un podcast qui est très intéressant sur l'observation de la Terre qui s'appelle TerraWatch Space. Et un blog aussi qui présente beaucoup de problématiques liées. Merci beaucoup à Ravi d'avoir accepté de venir et je te laisse la parole. Est-ce que vous voyez sur le Zoom, est-ce que vous voyez les nouvelles slides ou toujours les anciennes?
Oui, c'est bon.
Bon, ok. Use the keys for switching. If you can stay close to here, yeah, c'est bon. Okay.
Bonsoir, je vais essayer de me présenter en français. Je m'appelle Arvind et je viens d'Inde et je travaille, je suis le directeur de stratégie spatiale de Tomorrow. Tomorrow, c'est une entreprise américaine qui crée des logiciels météorologiques pour prédire la météo et ça utilise par beaucoup des entreprises mondiales comme Uber, Delta Airlines, JetBlue et beaucoup d'entreprises dans des secteurs différents. Et je suis le fondateur de TerraWatch Space aussi. TerraWatch Space, c'était une entreprise consulting et maintenant j'ai écrit et je fais des podcasts. J'arrête mes services de consulting parce que je travaille chez Tomorrow. Aujourd'hui, and now I switch to English. Today I will present an overview of Earth observation. So how many of you here have heard of Earth observation before, the word Earth observation? Okay, so half of you here, and I don't know how to, maybe I can conduct a survey on Zoom. So hopefully I'm assuming the same thing. Half of you have heard about Earth observation and half of you have not. So what I want to do today is just to give you an overview of how to think about Earth observation today. So that you can go back with an understanding of what Earth observation means, what are the companies that are working on Earth observation, and what can you do with Earth observation, just as a couple of examples. So as I mentioned, I work at Tomorrow, in case my French was very bad and you didn't understand. I work at Tomorrow, and Tomorrow is a company that creates weather intelligence software, and I will come to how we do things at Tomorrow in a bit, but we are also launching a constellation of satellites starting next year to gather weather data around the world. And I joined the company because I realized that weather is something that is not available everywhere in the world, like the way we enjoy it in the West. Half of the world, or 2/3 of the world, does not have access to weather data, which means that they don't get weather alerts, flood warnings, and as you might have seen in terms of the world we're living in with climate change, that's not fair, that half of the world, more than half of the world, does not have access to weather data. So Tomorrow, which already is 5 years old, was created to have a weather platform where companies can sign up to get alerts. So if you're a rail operator, you want to know if you can run the train from point A to point B. If you're a flight operator, if you're if you have a factory which is going to be affected by floods, you can get alerts through its platform. And now we're also launching a constellation because half of the world, like I mentioned, does not have access to weather data, and I lead the strategy for space at Tomorrow. And TerraWatch Space, as I mentioned, I write occasionally. I put out some podcast episodes with people in the space industry, from astronauts to people who created companies in the space industry to people working in space agencies. So I interview them in terms of what's going on in the space industry, not only about Earth observation, but overall about everything that's going on in space. So to get started, I want to get started, before I go to the slide, I want to get started with the space industry. So just to give an overview of what's going on in the space industry. I didn't include that in the slide, but two things that you need to remember is today we have access to space like never before. So earlier you can only launch on you had a choice of 4 launchers, NASA, ESA, Chinese, Indian, and sometimes you have the Japanese launcher. But today you have a lot of private companies. You might have seen SpaceX, but there are probably about 170, 180 companies today that don't have capabilities. About 20 of them can launch, but about 180 projects, including in France. There's you should have, if you haven't heard, you should check out Venture Orbital, which is a startup from Reims, which is doing an incredible job. And of course, we have Ariane from France and for Europe. So that's the first thing. Getting to space is becoming very, very easy. And 2, making satellites is getting very cheap, and satellites are also becoming smaller. So 2 important things that is applied to the whole of the space industry, but is more relevant for what we're going to speak about today, Earth observation. So Earth observation is just one type of satellite, right? Like you can have satellites to communicate, you can have satellites for weather, to predict the weather. You can have satellites for navigation, like Galileo, like GPS. So we have different types of satellites out there, and Earth observation is just one type of satellite. And yeah, it's on PDF. I'm sorry, it's a lot of text. I wanted to show a presentation where it was presented one by one, but it's a PDF. Sorry about so much text. So basically, if you just look at the first point, that's what I was going to focus on. The first point is, why do we have so many satellites today? About 7,000 satellites exist today in orbit, and over 50% are Earth observation satellites. So essentially observing the Earth. And it is enabled basically by 2 things. One is hardware, one is software. What is the hardware part? The hardware part is what I described earlier. You know, getting to space is becoming very, very easy and cheap, and satellites are becoming easier to manufacture. So a lot of people are trying to, manufacture satellites. Earlier, it was only ESA, it was only KINES, it was only NASA who can manufacture satellites. But today, if you're studying in a university, you can make your own satellites. So that's the big difference from where we have come. Only, institutions with huge budgets, billions of euros, billions of dollars can do it. But today, you can do it with tens of thousands of euros, and sometimes even cheaper, because everything is becoming democratized and easily available. So that's the hardware part. The software part is very, very important, because if you just collect data and you can't do anything with it, it won't help. We've been collecting data. So Earth observation is not new. We've been collecting data since the 70s. It started out as, as a spy satellite program. That's how the whole Earth observation came into the picture. Simply because the US wanted to understand if Russia was going to send missiles. That was the history of Earth observation is we have to, be aware of what's going on in Russia and see what they're up to. That's how the whole Earth observation industry started. And then eventually it started becoming maps. So everything that we can map out on the surface of the Earth. Earlier maps were physical, where you print out a sheet of paper and then you distribute it to people. That was maps. But because we started launching satellites and started understanding the Earth better, we could then make digital maps, so to say, because the satellites were collecting data about the Earth. So that's one side of it. And this is how Earth observation was being done. So you take pictures. And then you store it somewhere, and obviously every picture that you take is very, very heavy. But today you have cloud, which means that You don't have to, download your picture to your computer. Even this computer, it's a MacBook Pro, I think, it will break if you have to download 5 satellite images, because each of them is 2 GB, 3 GB. So if you were to try and download it and open it, it's going to break. But working on cloud makes that easy. So that's one thing. And the second thing, which is, I think, relevant for a lot of you here, is artificial intelligence. So I'm going to show you, of course, you've seen a lot of pictures of satellites. So there are no pictures of satellites that I'm going to show. There are a couple of pictures that are going to come. But what's very important is the ability to identify things. That's a house, that's a river, that's a tree. That's something that we can understand. And the beauty of artificial intelligence is you can tell a computer to understand. And it's great because you can have so many use cases, and that's where Earth observation becomes very, very interesting. Is you can just look at an image and then start to get a lot more details. So if you take pictures of Toulouse and you want to know why there is so much pollution in Toulouse, you take pictures of satellites from 2010, 2015, 2020, and then just try to count the number of trees. 2010, maybe there are 100,000 trees. 2015, 50,000. 2020, only 25,000. So, you can start to see patterns. And instead of you counting the number of trees, you can now teach a computer to count, and you can, start to understand. That's just one example. So the software trend is also very important in Earth observation. So the thing that people focus a lot is satellites, hardware, but the software is very, very important. And that's where, the whole advancements in cloud and artificial intelligence become very, very important. And as a result of that, the market, you see, market size, billions of dollars, it's okay. You just need to know that it's a huge market. It could be hundreds of billions, it could be tens of billions, it doesn't matter. But then the market is very interesting because, I gave 2 examples already, like counting the number of trees, counting the number of cars, and I'm going to discuss a few examples. And the beauty of Earth observation is there are just so many applications. You can, take the picture from fields, farms, and see what crop is growing. And then you can compare it with the soil and then see what is the best crop to grow on this land. Because with the satellite image, you can identify what type of soil it is, and you can also identify what type of crop that grows well. So you see there's a lot of applications that are across industries, and I'm going to go into 2 or 3 examples, but there are just so many applications, whatever your sector. And I used to play this game with my friends. Just give me an example of a sector. I don't know, car manufacturing. What does it have to do with Earth observation? You can relate to it. I'll show you an example. A supermarket. How do you relate to Earth observation? There's an example. The thing that is beautiful. The beautiful thing about Earth observation is that the application is everywhere, and we're using it almost on a daily basis. Either us or the companies that serve us, we just don't know. And there's a lot of potential to come because of what I'm going to show. And what I'm going to show is the way to understand Earth observation. So it's a very, very complicated infographic, super crazy with all the logos, but let's make it easy. The way you can understand Earth observation is, let's start from the bottom. What we know about Earth observation is it's a type of data. So, you would have heard about metadata, you would have heard about advertising data, you would have heard about economic data. Like that, this is just another type of data. It just happens to come from space. The data that's being collected is just coming from space. So if you look at the bottom layer, data, that is what people talk a lot about. And that's where all the satellites come in. So Airbus is launching satellites with Earth observation satellites. One of the companies, I don't know how many companies here you might have heard of, but there are just a lot of them. What they're trying to do is to launch satellites with different types of sensors to go to space. So when I say different type of sensors, it means that if you look at, if you want to look at the emission, like the pollution, you need to launch a different type of instrument compared to if you just want to take pictures. So the satellite picture that you see on Google Maps is a different satellite, and the satellite that takes emission pollution picture, pollution data is a different satellite. So all you need to understand is they're all different types of data, so fitting into the data layer. And if you go one layer above infrastructure, what's important is, I told you earlier, there's just, if you just put up a satellite there, and there's a company called Planet that you see on the logo, and some of you might have heard of Planet. So Planet has about 300 satellites, and they take a picture of the Earth every single day. Every single day, they just take a picture of the Earth. And today we've been using it to find out how trees are being cut in Bolivia every day. We have data about how many trees are being cut in Bolivia. Rainforests, you might have heard of how many rainforests are being cut every day, every year. So we have data to prove that. We have data to see how much concentration camps are being built in China, for instance, again, with the same type of data. So they're collecting all this type of data, and they need to store it somewhere. Clearly, they can't store it in the computer, and cloud provides a way to do that. So you see the names that AWS, Azure, Google Cloud, and there are a few European initiatives as well. So Blue is from Airbus, and there are a few others coming out of Europe. The logos that you see in this layer, the second one. And the thing with, and I call it infrastructure because it's the infrastructure where data is stored. Basically, that's basically that layer. And then the next part is platforms. So platforms is areas where you can go and access satellite data. So that this data is being collected. That it's being stored in Amazon or Google or SoBlue, wherever it is, but you need to find a way to access it, right? Like if it's just stored there somewhere, it's not useful. You need to be able to use the data and work on it. And that's where platforms come in. Again, a lot of logos here, but then their job is to provide you access to the data. So instead of just having the data there, you can have access to that data. So that's the platform bit. Before I go further, I wanted to go to another slide, which I think could be very useful for you to understand Earth observation, is to look at the four-step process here. Data availability. So what type of EO is Earth observation? What type of data is available today? That's the first thing that you need to be, asking yourself. So what is the type of data available today? Is it the data for pollution? Is it the data for agriculture? Is it the data for insurance? That is the first step for you to understand, what can I use Earth observation data for? Maybe you're working on projects where Earth observation data is useful. And I mentioned, a lot of examples, and I'm going to go through some examples. And the second thing that you need to look at is accessibility. So where can I access the data and how can I access the data? Can I use an API? Do I need to download it to my computer? Is there a way that I can link the download of data through an API? These are all questions that you can understand by looking at platforms that I showed earlier. And then what can become very interesting is feasibility is not a real word, it's a word that I invented, but how can you combine the satellite data with other types of data? Because if you just have a satellite image, it does not mean anything. Sometimes it could mean something. For example, I gave you the pollution example. You can count the number of trees in an area in Toulouse in 2010, and then in 2015, it makes sense. But then if you're looking at another example of taking in the number of trees and then seeing how much this relates to pollution, then you need other types of data. What is the pollution level of Toulouse? So you need to be able to fuse different types of data together. That's an important thing that you need to be aware of. And then finally, data usability. What is this data used for? So essentially, the problem with Earth observation today is there's a lot of types of data available, but people don't know what it's used for. And that's the important thing that we need to figure out. And what I'm going to do to help you understand that is by looking at this. So this is just a infographic that I created based on different type of sensors. So I told you that there are different types of sensors, right? So you see that there is a sensor called optical. So optical sensor is basically a sensor that what we can understand. So if you see an image like this one, you can understand. So this is an optical image. This is an optical image. You can understand it. So that's an example of an optical image. And there are a lot of companies working on, again, there's a lot of companies. There's also free data, open data from projects like Copernicus in Europe and Landsat in Europe, in the US. So there's a lot of data in the optical side. And what the problem with the optical side is they're just cameras. It's like a camera on your iPhone in space. But the problem with that is what happens if it's dark? Is there a flash? What happens if there's clouds? You know, it's useless because if you take a picture from space, it's just going to be a cloud picture. So what we have is called radar sensors or SAR sensors. And there are, again, a lot of companies working on it. And the beauty of radar data is that you can have, it's basically a signal that's sent from space down, and then it comes back up. So it's just a reflection of a signal. So it's called an active sensor because it's not just taking pictures, but it's actually sending a radiation, which is then reflected back. So that's the radar sensor. And again, the advantage of radar sensor is that you can use it for continuously monitoring. This is what was used and is still being used in military. You can not depend on optical, you know, imagine you're in a war zone and there's clouds. It's a useless satellite. So you need to have radar. So radar is not only useful again in military, but again, for monitoring what's going on during a flood. So if you have heavy flood, if you have a cyclone, if you have wildfires, you don't know what to do because there's a lot of cloud or smoke, and an optical sensor will not do justice. So you have radar sensor for that. And on the top right, you see radio signals. And again, a lot of logos. Unseen Labs is a startup actually from France. I don't know how many of you have heard of Unseen Labs. It's from Rennes, if I'm not mistaken. And what those type of companies try to do is they just look for radio signals coming from different parts of the world. So if you're a ship and you're going on the sea, you emit radio signals. So that's one type of example of sensors that you can send to orbit. It's not only for ships. You can look at where people are living. So imagine that you want to find out if you have pirates on the sea. You know, pirates usually, you know, they don't switch on their lights and then they don't want to make themselves active, but they still emit radio signals. So again, those satellites from those companies help track that. What's interesting, and there is a part about hyperspectral and infrared. So infrared is, like the name suggests, it's an infrared sensor. And as you can imagine, infrared is all about heat. So if you want to know what is the temperature of over an area, you can use infrared sensor. If you want to find out wildfires, so you know where fires start, you know, I think even in France this year, there's just been a lot of wildfires all over Europe. You would have seen in Greece. So what infrared sensors allow you to do, again, from space, is you can find out where the fire is starting and you can predict how it's going to go. Again, infrared sensors allow you to do that. Hyperspectral is an interesting case because what hyperspectral does is it measures different types of wavelengths. So you can measure emissions. You can measure or you can identify a type of crop. Is it rice or is it wheat or is it maize? You know, hyperspectral sensors allow you to do that. So those are all the different type of sensors. And what's interesting that's coming all of that is there is a part called onboard processing on the top. And it's the other name for onboard processing is edge computing. Maybe edge computing is a word that you'd have heard of. Edge computing is as the name suggests, instead of downloading the image on the Earth and processing it here, imagine if you can do that on the satellite. Today, 10 years ago, it wouldn't have been possible. But today, you can send a satellite that has a computer in itself, which can identify a tree, which can identify a building, which can identify water in space, so that when you get the image down, it's already done. You know, the work is done. You don't have to do it. So we are moving towards that world. That's what I want to highlight here. That's also a type of satellite that is coming up in the future. It's in very early stages today, of course, but then it would be great to have a world where we have satellites. Instead of just giving you data all the time, it can give you, you know, processed insights. So it can give you, you know, it can't just give you an image, but it can give you an image with things identified. So that's the world we're going towards with respect to sensors. So those are all the different types of satellites. I don't know if it makes sense, but these are all the types of satellites that we are trying to send to space. And I'll come to some applications in 1 minute. What I want to show here, it's not very super relevant, but what's important to know is that I call it verticalization. It means that you choose an industry and then you decide what type of data is useful for you. So there are companies that have decided. So let's take an example of Spire or GSG Sat. So GSG Sat on the left that you see is a company that is launching sensors only for emissions and climate. So their satellites are not going to take pictures. Their satellites are just looking for emissions. Where is methane coming from? In which part of the world? So that's their goal. If you compare that with, you know, companies in the bottom, they're all companies that are trying to send sensors that are taking pictures, you know, optical or radar, but they can be used in different industries. So you have two types of companies. That's what I wanted to show here, but it's not very important to understand. Now, coming to an example, I'm sure that Florian mentioned that the next week you will have a detailed example of how you know, satellite imagery is used. And I wanted to just use one example here. So this is an image from Airbus, an image from this Airbus satellite. So one example of how people have been using, especially in the last year, is that's an image of a supermarket, a parking lot of a supermarket. It's just a parking lot, you know. If you just don't look at it and think of an example, it's just an image. But then what people have started doing is use this to identify lots of things. Number one, they used it during the pandemic to figure out, based on the number of cars. Again, if you compare 2019 on November 9th, there were 100 cars. And then they compared it with April 2020 to figure out that there are only 5 cars parked. So what is going to be the impact on the supermarket? You know, that's something that was done by the government, used it all over the World Bank, all of them used these kind of images to identify, you know, just by the number of cars, what is the impact on the economy? Because if you can make models and estimations based on, if you only had, you know, this many number of cars, this is the impact. And that's what you can see on the graph today, graph on the bottom, is that over a period of time, how it has changed. So that's just one example. Another example is, imagine if on the left side is, I don't know, supermarket one, that is Carrefour. And then on the right, it is Monoprix. You know, you can do like competitive strategy. And if Carrefour has access to this imagery and then they compare how many cars are parked in Monoprix, they can get a sense of why is so many people going to Carrefour at 2 p.m. You know, how can we attract them better? You know, things like that. So more like competitive strategy. Again, that's a very different example compared to another one that I'm going to show. That's just to give you an idea of what are the possibilities with satellite imagery. You would have just, you know, you probably have seen this on Google Map and, you know, just left it because it's just an image. But then if you think about it more, think about it strategically, it can be used for a lot of things. And going back here, I want to highlight the importance of artificial intelligence. You know, you're not going to go and count the cars one by one with your hand. If you teach the computer to do that, it becomes very easy. You can set alerts. You know, if you're working on this, you can just set an alert saying, if the number of cars is greater than 50, give me an alert, because it can be used for a business decision. So that's where artificial intelligence comes in. And I think that's what you guys are, you're data science people, and that's an interesting challenge. Is it's not figured out. I'm saying, it's easy to count the number of cars, but it is very, very hard because the computer vision availability today is just not great, and the efficiency of algorithms are not great, and there's a lot of training to be done, because for a computer to understand an image like this, you can identify a car, but then you take another image, the car looks very different, and it's a huge challenge from an artificial intelligence point of view, because you cannot train a computer when in each image everything looks different. Imagine there is a small light cloud over the area. It's a very different challenge because the car does not look the same. The color is not the same. So it's a huge challenge, and there's a lot more work to be done. And I'm sure that if you look into this area, there's a lot of work being done today. Another example is in the insurance industry. So you remember the incident in Lebanon? I think it was last year or 2 years ago, when there was a huge explosion. They had to find out what was the impact of this explosion. How many buildings got affected? Clearly you can't go into the area to see what happened to the building. If you're an insurance company and someone's asking you for a claim, you need to know, how many buildings got affected. What is the level the building was affected? Again, satellite imagery allows you to do that. And the beauty is, again, I go back to radar. There was huge smoke. Optical imagery would not have helped because you only see smoke in the image. So having access to radar image, the one that you see on the right is radar, and whatever you see in pink is the area affected, the building that was affected. And insurance companies use these images to get a sense. Again, artificial intelligence is used here because you need to know what a building is. You can't do that, by hand. People did that before, but today with artificial intelligence, you can, automate that. You can recognize buildings easily, and then you can pass the information on to insurance companies for them to figure out what to do. And going on to something completely different. Again, this is also with Earth observation, but I'm going to take an example from my company. Is obviously you have seen, storms. I think you've seen pictures like these when you look at the meteo on TV or in a computer. This is also from satellites, right? So this is also Earth observation. People don't think about it a lot, but this is one of the success stories of Earth observation, because Earth observation today is in a way that, I have to explain every single concept to you, but weather is like a success story. You just know it works, right? Like you haven't, unless you study meteorology or someone who's a meteorologist, you wouldn't know what goes on really with weather. How are they able to predict how the storm is going to go? How are they able to predict amount of rainfall that's going to happen? Is it going to be light rainfall or heavy rainfall? How are they predicting that? So all of these are data science challenges, essentially. Of course, you need to be a scientist to understand and predict this, but essentially it's a data challenge. And what we do at Tomorrow is also something similar. We're going to launch our satellites starting next year to get more data about the weather. And what we do is we offer a product like this, and it's different from what you've seen before, because our customers use this. They don't know that data from space is being used. They don't know, the science, the technology behind it. What's important at the end is if you're a customer. So this is an example because it's used. I don't know if you can read it. Here it says, imagine you're a construction company and you want to know if you can operate your big crane or not. If there is heavy winds, you shouldn't. If there is heavy rainfall, you shouldn't. So essentially what we do is we just tell them, oh, there's going to be high winds, suspend your operations. As a customer, that's what they care about. Should I run my crane or not? Should I run my train or not? Should I run my flight or not? They don't care about the satellites. They don't care about the AI. All they care about is what should I do, right? So that's an important part of Earth observation. Well, it's also an important part of any product development, is that you need to build a product at the end that just answers the question for a customer. So I talked about so many things before, hyperspectral, radar, none of that matters, right? Like if you're an insurance company, I just need to know if this person is asking for a claim, he says that his house was burnt, you just need to find a way to figure out if his house was burnt or not, right? So none of that matters. Did you use AI to find a building? Did you use image from Airbus? Did you use an image from NASA? You know, they don't care at the end. Essentially, after all of this, you know, it's almost like bad news because none of that matters, because at the end, your product is, you know, everything runs in the background. And that's why I said weather is a success story, because you just know, you know, you look at your phone and you just know tomorrow it's going to rain. You don't think about it too much. And that's the best case scenario for everything else that's going to happen in Earth observation. I talked about this slide before. Last thing I want to show is just some examples of companies. I wanted to present an entire ecosystem of companies, but I wouldn't do justice because I'm going to miss a few companies. There are so many companies in Toulouse, but then I just put on some, well, popular ones. So I start from the bottom. Of course, you know Airbus. Airbus has lots of satellites. It manufactures satellites. You would probably have heard of Airbus in different ways, but Airbus, from an Earth observation point of view, they have satellites, they have data, and they also have products. And Unseen Labs, I told about before, they're a startup from Rennes, and they have satellites on the radio frequency side. And then Prometheus is another startup that's coming up. Geosys is a company actually acquired by another company called Earthcast. It's based in Toulouse, and it does agriculture related products. And SpaceX is a startup based in Paris. SpaceX has an API that you can use to figure out if I need to you know, put the fertilizer on my crop or not. You know, they answer the question. Like I mentioned earlier, at the end, what matters is, you know, should I water my plant today or not? Should I put fertilizer or not? And SpaceX is a company, again, that helps you do that. And two examples of companies on the top are companies who you have no idea if they use space or not. AXA Climate, AXA, you know, the insurance company. You know, I gave an example of the insurance use case of, should I insure my house or not? That's all you care about, right? You don't care if it's useful in, it's using Earth observation data. You don't care if it's using artificial intelligence. And, you know, AXA Climate is an example of that type of company. Descartes Underwriting is an example of another startup based in Paris. They look at, again, from an insurance perspective, they are an insurance company. They use satellite data today, they use Earth observation data, it uses artificial intelligence, but then going back to what I said before, it's about building a product that has everything inside it. And that's what Descartes, that's an insurance company, does. So I hope that gives you an overview of Earth observation and what Earth observation is, what it can be used for. I try to cover as much as possible, but of course, one session is not enough. So if you have any questions, let me know. I have, you know, if you didn't understand a lot of what I said, you can go and read what I wrote on my blog or my newsletter. And yeah, or also listen to my podcast where you will have other people explaining what I just explained. At the end, I just want to say it's a very, very exciting industry to be in, because one thing that I always tell people about Earth observation, this is the most amount of data that is ever collected in the history of humanity about the Earth. It can be about the atmosphere, it can be about what we are doing to the Earth. We are collecting all this data, and we need to put that to good use. It can be for solving climate change, it can be for monitoring pollution, it can be for insurance, whatever it is. But then the important thing is, this is the most amount of data ever collected in the history of humanity. You know, it's not, you know, of course there is the, you know, gigabytes and terabytes of YouTube videos or, you know, advertising data lying somewhere. But then this is, you know, very useful, purposeful data of what we're doing to the planet, what we're doing to ourselves, and there's a lot of work to be done in terms of using this data, because today it's just data, and we need a lot of support from data scientists, artificial intelligence experts to make sense of the data. So that's basically the last thing that I'll leave you with. Thank you.
Any questions in Zoom, or I'll take a managed question on Zoom. Don't hesitate to unmute yourself.
Yes. Well, first, thank you for your speech. I am Frédéric from Promete. So thanks also for putting the focus on the new companies in France. I just have a question about your use case. You described about weather and a very specific application like airport operators, train operators. That's what they want. It's a proposition, an actionable proposition for what they have to do. How did you manage to get to this point, to very close to the end user? Did you use like models? Did you use a sample of different end users? Are there some regulation standards saying that at a certain level of rain falls, you have to stop operations? Or is it because I imagine there are some different cases, depending on the region, depending on the regulations? So how did you achieve this very end-user focused service with the weather?
Well, the answer is easy, because it starts from the user. So if I can go back to one thing, it's back, right? One thing is, it's to start from here. It's to start from what is this data used for? Instead of starting at the top, what is the data available? You start from the bottom. What is the data used for? Is the data used to tell a user when they should not run their train? Is it used to tell a government where the pollution is coming from? Instead of starting from the data, you look at the image and then you think about, what can this data be used for? You start from the user. The user will then tell you what he wants, because a lot of things, the biggest challenge in Earth observation today is, I told you, we are collecting more data than ever before, but then we are not using it because we don't know what to do with the data. I'm giving you, a talk here, and I've given plenty of talks in different places to tell people what we can do with Earth observation data, because not a lot of people know what Earth observation data is. What is Earth observation, first of all? Because the only thing that they can think of Earth observation is Google Map and how they can see the satellite data on the Google Map, but they are not thinking of all these use cases. So the answer lies in going to the user and figuring out what this user wants. So in this case, construction company, any construction company in the world does not want to run their equipment when it's raining, So you can think of a product. Okay, the company does not want to run a crane or any big machine when it's raining or when it's heavy winds, high winds. So, you start from there and then you see how to solve that problem. So in our case, we started with the user. I think that's the answer. The simplest answer is we started with the user and then we worked backwards. And that's also how we decided to launch our satellites. We did not want to launch our satellites because it's possible. We wanted to launch our satellites because there is no data. And the only way to solve that data is to go to space. We can collect data. Actually, the company did try. The company Tomorrow.io, the previous name of the company was Clamacell, because they thought they can use cell phone towers everywhere around the world to collect weather data. And they tried it, but it seems like that is not very scalable. And the best way to do it is by going to space. So that's how we decided to go launch our satellite. So essentially the answer lies in starting from the user, asking what he wants, and seeing what is the best users for your product or the best customers, seeing what they want, and then trying to build a product for that, as opposed to starting from the other side. I hope that answers the question.
Thank you.
Yeah.
Thank you for the talk. It's super clear and super interesting. So I have two related questions. You gave the example of like the United States spying on China. So the first question is, are there regulations to I guess I mean we are not like France is not allowed to get some emails from the Pentagon or things like that. So I guess there are regulations or not. And then also like do institutions do some kind of what they call in machine learning these adversarial attacks to fool the satellite, like to you know what I mean, like the thing that make to fool the camera.
Yes, on the first question, yes, there are regulations. So in the US, the regulations are the highest. Well, actually, it's very relevant because only last week there was regulation published in the US which stopped companies from giving data like very, very high resolution. I didn't get into technical details, but there is things that's called the resolution, right? Like what is the level of quality of an image? You know, there's like very, very high resolution where you can find out, you know, probably not a person walking on the street, but it's not impossible. You know, there are companies now promising images that are very, very high resolution. So the US passed, or they have a policy now that says companies cannot use or companies cannot sell their data if it's of very, very high resolution, which allows for almost spying. And unless it's for military purposes and unless the customer is the military, you cannot sell that level of quality of data. And there is both good things and bad things about it. The good thing is, how did we know that North Korea was about to test a missile? Only because we had data from a commercial company, and only because there was a reporter, an investigative reporter, who decided to look into it. So, you know, there's only because the data was open that this was discovered. How do we know? Again, there was a ship. China was, you know, sending a few ships in the China Sea a few weeks ago, a few months ago. Again, through satellite data, and we will all know that. So it's a question of, and the bad thing is, you know, you can in the future, if that's the future we're going towards, you can see what your ex-girlfriend is doing on walking on the street. You know, it's also possible because the resolution of data can allow you to do that. You can take a picture of this part of Toulouse and see if the car of your friend is outside his house or not, and helps you to spy. So that's the bad thing. Do we really want a world, you know, imagine where we are with respect to technology. Do we really want a world where anybody in this room can, you know, have access to this type of data? So it's the good thing and the bad thing. And I think honestly, we're still figuring that out, and hopefully we'll figure it out before bad things come out of it. Because the good thing is, not a lot of people understand this. You know, a lot of people don't even know this data exists. So we need to figure out the regulation part before. So on the US, this is the case. In Europe, we don't have these regulations because we don't have satellites. You know, there are some military satellites. So French, they have France has their military satellites, and they also have very, very high resolution image. It's just not open for everybody because it's a military satellite. But then soon we will have companies that launch the same quality or better quality, and who is going to regulate that? We don't have an answer yet, so hopefully we figure that out sooner. So that's the first question. The second one, well, it is possible to fool, but then the difference is when you can process the data on orbit. If you're just getting the image back down, you cannot, you know, change the image. What the image is the image. Today we're using it to, you know, tell Turkey that they emitted methane more than they should, because satellites, you know, I told you about a type of satellite that allows you to monitor emissions, methane or carbon dioxide, whatever it is. The same type of satellites today are telling the truth. So satellites are essentially a way for you know, it's the highest level of truth that's possible. You know, you cannot fool, if you're a country, you cannot fool that you're meeting your carbon targets, because you can see that from space. If you're a factory, if you're, I don't want to name any names, if you're an energy company saying you are, carbon neutral, but you see from space that, you have a lot of methane emissions, it can only be the truth. We haven't reached a point where the downloaded image is already, faked, so to say. But to answer your question, can we, change the satellite image, just like how we're doing deep fakes, right? Like, can we do that with satellite imagery? Of course, that's the case with any type of image. If you want to change, today you can even change a video with deep fakes. So can you really fool with a satellite image? Of course, I hope that doesn't happen, because we can always go back to the real image. It's a question of, where you got access to the image, and that's why, I want this data to be available to everybody. But then the problem with having this available to everybody, just like anything in the world, is it can also be used for bad. If you have access to this imagery, and you just decided to put the methane emission from Turkey to, I don't know, another country, and you start sharing this image, and this image goes viral saying, oh, France is emitting methane, and people start believing it, you can't do anything with it. So that's the problem with getting this data open to everybody. But the best case scenario is, if you have this data open for everybody, then you can develop a lot of applications, just like we're doing with the App Store. If you don't have Android that is for everybody who can develop an application and submit it, you can get a lot of useful apps, right? So that's my future hope for Earth observation, is it becomes like Android, where, of course, are there like shitty apps on Android? Yes, right? You can create apps to do whatever you want, but then mostly it'll be good applications, and it's the same case, I hope, for Earth observation.
But I've heard like some years ago, I don't know if it's true or not, but for instance, in Europe, there are like some farmers that, you have subsidies depending on how big is your land, how many trees you have.
Yeah.
So there were trees that people did like and it put like the plastic, whatever, or something to paint the. I don't know how they did it. And apparently they fooled the images. I don't know.
Oh yeah, no, of course. Yeah, maybe it's a question of how you use it. Today, could have probably included that example. Today we have a project called FAST in Europe, FAST. And the FAST platform is being used by governments in Italy, Spain, Estonia, about 8 countries to do exactly that. And the thing is, the software was developed by the European Commission to help countries, to help farmers know when to fertilize their crops. And after COVID, it was used for people to apply for subsidies. If you're a farmer who had wine and your winery was destroyed because this year there was a lot of problem in France, you can apply for subsidy, and the government, European Commission, will verify that using satellite imagery. And the beauty is they have satellite imagery from different time periods. So even if you're trying to fool them, they can go back in time to figure out, you said you are a farmer growing whatever crop. You can go back 6 months to figure out if that's what you're doing, because satellites can allow you to tell the truth. You can try and fake it on that day, but then you can't change the past. And the beauty of satellites is it's not a single source of data, right? It can go back in time and you can verify it. And that's the good thing about satellites. And going back to my previous point, that's also the good thing about the whole of, the concept of Earth observation, is that going back in time is crazy. Like, you can figure out so much. And if it's just one point of data at this time, you can fool somebody, you can, it will tell a different story. But then if you just create a time lapse of images of, each month, you can learn a lot about different things. Like I did that over Paris when I was living in Paris, to figure out if the number of cars in Paris reduced over time. But unfortunately, I did that over 3 years, and I figured out the number of cars increased in Paris. So of course the pollution went up, right? So you can do a lot of things with, you can take the picture of Paris on a single day and say, oh, there are no cars in Paris today, but then, you just see a trend, and satellites allow you to do that, right? Because you have data available, and that's the beauty of satellites.
First of all, thank you for the talk. You talked about, I think it was called onboard processing, the satellite.
Onboard processing, yeah, edge computing.
When and why is it better to process on the satellite instead of processing on Earth, which I figure it's easier to host the processing power?
Yeah, no, of course. That's why I think we haven't reached a world where you can do everything in space, everything on the satellite, but you can do very simple things. So, the example that I gave you of finding the cars, that is actually an algorithm that is almost perfect today, because we have gotten so many types of satellite image, and the algorithm has reached a point of efficiency that it's going to work. And it's the same case with something called agriculture index, let's call it like that. You can look at a picture of a plant and tell if this plant is healthy or not healthy. It's super easy, because all you need to do is just take that image and see what is the level of green. Is it green level 0.7 or 0.9 or 0.3? It's a super easy kind of algorithm to write. So the algorithm is, if this image, the value is greater than 0.5, the plant is healthy. If not, the plant is not healthy. This is something that can be done in space. This is a very simple algorithm. All you need to do is identify what is the plant, which is kind of easy to do if you can train the model of just seeing the green. And then, set a value for this, the algorithm. So this is a very simple algorithm which can happen in space. And the advantage of having this in space is it can be fast. The time you get, by the time you get the data down, you can already make a decision. So the agriculture was probably not a good example for this, but think of insurance, think of weather. So for example, what we are trying to do is we have to identify, let's say, a storm from space, and collect the rainfall data, how much rainfall is falling over a period of an area. It's a very simple thing, because you don't have to download the data, because it takes time. The satellite needs to be above a ground station so that the data is downloaded, and then the data needs to be transferred to a cloud for running a very simple algorithm. And it makes things very easy, because there are some problems where you need to have, data is good, but you need more than data. You need like the next level. You need information from the data to make decision. And again, the simplest example that I don't like to give, but the simplest example is in defense. You can think of a lot of use cases where, instead of telling there is a building nearby or 2 kilometers away, let's assume you're in a war zone, and there is something that you didn't notice when you did a surveillance, and you can only see that from space. You got the data, and you need to download the data, you need to process the data, you see where the building is, and then you need to communicate to your troops by using onboard processing or edge computing. The building is already recognized. You can get the data and you can just pass the information. You don't need to waste time running the algorithm. So defense is the simplest example. And what I also forgot to mention is the biggest customer for Earth observation today is defense. So I told you the whole history started because of a spy satellite. So the biggest example of use of Earth observation today is in defense. So defense is the simplest example. Good.
Yeah. Any question on Zoom? You can unmute yourself. Any? No. Okay, thank you very much. See you in 3 weeks, everybody. For those who are in the room, I invite you to go to the kitchen and eat and drink something. and we can continue the discussion there.
Merci.